Get started. Thank you to the organizers, you three guys. I mean, you're doing a really great, four guys, sorry, doing a great job keeping us going on JSTL, and I really appreciate it being able to come to this meetup. So thank you guys. Thanks everybody for being here. Tonight we're going to be exploring maps and JavaScript, like it says up there. My name's Gavin Raykemper. There's my website, Twitter, whatever. And the bit.ly up here, bit.ly/JSTL maps 19. That will be a link to the GitHub for this talk, so you can see these slides. The links are embedded and all that good stuff. So feel free to follow along as I go. I'm a software engineer at Esri, which is a mapping technology company, but I'm not representing them tonight. I'm really just here out of the love of maps and the love of mapping technology. I really find it fascinating, and I really enjoy it. So I wanted to kind of explore some of the mapping libraries in JavaScript and how you can use them tonight. So speaking of maps, who can guess what this map is? Of time zones, yeah. Okay, great job. This is really just a simple map, right? It's not very complex, but just in this simple time zones map, it kind of is very interesting. Like you start to, as I look at it, I kind of start to wonder, right? Like what's with these nubs in the time zones, or you can almost see the continents in the time zones in some sense, and I really just like maps that can really cause you to be interested or curious about a topic. And as you dig into a topic like time zones, you can kind of find better maps on those time zones, and you can kind of start to understand some of those things, right? So this map, I know it's probably hard to see in the back, but you can start to understand why these nubs are here, right? Those are islands, and those island nations are trying to stick with the time zone of their mainland usually. But there's some really weird outliers, right? Like Iceland is 2 time zones over, but it actually stays with UTC or Greenwich Mean Time. And then you can see interesting areas too here, how it goes around Brazil or whatever. I just find it fascinating. You can find really interesting stuff in really just a basic map, and I really like that about maps. Another thing about maps is just the amount of data that you can expose through a map, right? So if I take a basic data set, here's a data set. I downloaded it off of the St. Louis City Open Data website a couple days ago. It's of all of our parks in the St. Louis City. And you can kind of start to read through this, but it's kind of hard to really grok, right? You really have to kind of look at it, maybe sort it really to understand this data set. But if we put that on a map, we can immediately start to get a sense of what's in that data set, right? Like where are the largest parks? Where are the smallest parks? Where are there spaces where there's no parks and maybe we should put parks? That kind of stuff. When I put additional layers onto this map, like the St. Louis City boundary, you can kind of get more context into that data. You can add more layers, like some label layers. It's probably hard to see in the back, but Forest Park is labeled here, all the different parks, and you can kind of start to connect to this map and connect to your personal experience, right? I was at Forest Park last week, or I live next to this park. Putting even additional layers helps you to more personally connect with it. These are the St. Louis neighborhoods that we're layering on. And you can really start to see, you can see some of the design of the parks, right? So especially up in North St. Louis in this area, you can really see how there's one big park per neighborhood. And I don't actually know if it was designed like that, but you could guess that it might have been planned out like that. And then of course, the reason I'm here today is that you can get even more interaction with your map if you put it into a JavaScript library. So opening up this map, I can actually zoom in. I can pan around. I can take a look at, maybe I'm interested in this map. Maybe I live near Adams Park. I can click on it, see some more information. So in that sense, maps can really help you or your users to really engage with data, engage with your application. So all of that is nothing that you don't know, right? We live in a great time nowadays. We have Google Maps has been around since 2005, which is a really long time. That surprised me. We have maps in our pocket. We use Google or Apple or whatever you want on your phone to navigate around the world. It's really great time for understanding location and understanding the world around you. Being able to render interactive maps in your apps and in JavaScript is an extremely beneficial skill, I think. And the technical aspects of doing that is kind of what I'll focus on for the rest of the evening. The great news is that you don't have to build it from scratch. There are a lot of libraries out there that will help you build interactive maps in your web apps. These are a few of them up here, from Cesium, Leaflet, Mapbox. You've probably heard of some of these if you haven't used them before. The three libraries I'll talk about tonight, I just chose kind of three of them, tried to get a general cross-section of those libraries, is the ArcGIS API for JavaScript, the Leaflet JavaScript library, and the Google Maps JavaScript library. Google Maps, because it's pretty popular in the consumer space and lots of people use it. Leaflet is also quite popular as a kind of lightweight and open source mapping library. And the ArcGIS API for JavaScript is like feature rich, it's geeky, it has 2D and 3D, and it's kind of what like enterprise and professionals use. But before we jump into those, and I wanted to take a detour, all these mapping libraries use kind of common geographical concepts behind them, and I wanted to kind of go through a few of those. So the first, as I've kind of referred to at the beginning of my talk, are layers. A layer is just a visual representation of a geographic data set on your map. Layers come in two different types, either vector, which means the data is actually stored like either in a database or in JSON or whatever in terms of the actual values, like typically latitude, longitude, or some other type of data. And then raster, which means that the data is actually stored almost as an image in pixels, either on your server or wherever, and it gets pushed to the client and then just draped over your map. Adding multiple layers to the map is kind of where you start to get these relationships, and that's kind of what I tried to show earlier. It's really between the interplay of layers is where really compelling and interesting maps, where that kind of happens and where people can really start learning. The base map is just what it sounds like. It's the first layer that all of your maps always have. Typically, it's a background reference information, and it usually contains like roads, landmarks, political boundaries. This is the ArcGIS website, and you can see some of the base maps here. There are different types of base maps, and people design them for particular reasons, right? So if you're building a transportation app, you might build an app that's really focused on roads and transportation. And that's actually what Google Maps is really good for and what it's kind of known for. But you might want to choose a different base map if you're doing something else, right? Like if you have data that you really want your layers to pop, you might pick a more subtle base map, like a dark gray here. That will really let your layers kind of be shown off. Or if you're really focusing on oceans, there's base maps that really focus on like the oceans and the topography of those. So that's kind of one of the first things with map design, especially on the web, is kind of thinking about the base map that you have behind your data and making sure that it's complementary to what you're trying to do. Geometries are kind of the primary types in mapping world. You've got your points, which we're all familiar with, typical lat long. You've got lines, which are basically two or more points all connected together. And then polygons are multiple lines all connected together, connected back. And so those are kind of the building blocks of the geography of building these maps, and everything is kind of built off of those core concepts. These can be stored in Here's kind of storing that data in like what we call vector format, right? This is some GeoJSON, a very simple GeoJSON, a single point. So you can see it's saying it's a geometry, the type is a point, and then it just gives an array of the coordinates x and y, lat, long. So it can be as simple as that, and then it gets more complicated from there. So speaking of latitude and longitude, our world is actually a sphere, right? And actually not even a perfect sphere, but we won't even get into that. Lots of people like to think about when it comes to spatial references, if you want to take the globe and put it flat on a table, kind of like this video here, how would you do that? It's actually kind of complicated, and we'll see what they're going to do here. Right? It's got to be pulled apart in different areas. And that's kind of the challenge that cartographers have when they're creating maps of the Earth. So the methods of translating kind of the 3D world into a flat 2D map is called a projection, and a spatial reference is the identifier of those different projections that we have. There's probably thousands. There's lots of different projections. Everyone's created one, and there's like different areas of like, it's a whole science just creating projections. But luckily, we as simple developers, JavaScript developers, we don't have to worry about all those necessarily. The main two that we want to worry about, the first one is 4326, also known as WGS 1984 or WGS 84, and that would be what we call the traditional latitude and longitude. So if you ever see that, 4326 or WGS 84, it's generally just saying latitude and longitude. 3857 is Web Mercator. Web Mercator was actually created for the web, as the name implies. It was created, I think it was created by Google in the early 2000s for Google Maps. It's a variant of the Mercator projection, and it's kind of the standard for all the mapping applications that are on the web now. It was designed with that kind of purpose in mind, and basically everything uses it. The good thing is that you can easily convert between lat long and Web Mercator and vice versa. So even though most of your web maps that we'll be working with in the web will be in Web Mercator, a lot of the data you'll typically get will be in latitude and longitude, and it's fairly trivial to kind of put that stuff on the map. And lots of the libraries even kind of abstract that away, so you don't even have to worry about that as a developer. Okay, so you're probably wondering, when are we going to get into the code? I'd say let's do it. I'm going to go through a bunch of demos here for the 3 mapping libraries that we talked about. The first one being Google Maps JavaScript API. I would say Google Maps is great for basic maps, or when you're trying to get one or a few points or polygons or lines onto a map really quickly. I think, like I said earlier, a lot of like consumer-facing websites like to use Google Maps. They've got data included, like business data is automatically built into the base map, and it's a really solid API. They recently had some cost changes, so in the mapping world, we've kind of seen some people moving around in their JavaScript libraries because some people who used to use the Google Maps APIs, it kind of didn't make monetary sense. So that's something to be aware of. Basically, everything nowadays, if you want to use the Google Maps API, you have to register an API key. And there's definitely a free tier, but at a certain point, with a certain amount of usage, you have to start paying. So this is what your basic Google map looks like. Here, I'll make this bigger. This is what your basic Google map looks like on the web. You've got your 2 buttons at the top for map and satellite. You can even turn on terrain. And by default, the zoom buttons come in at the bottom, and it even comes with your street view built in. Obviously, you can turn these things on or off, but this is kind of the default view. And it's the same view that I think a lot of us are familiar with working with Google Maps on their website. If you zoom in, like I mentioned, you'll start to see see points of interest and businesses pop up right here. And that could be good or bad, right, depending on what you want to do with your mapping application or your website. So that's just kind of something to think about in terms of your choice. So how does this all work? So I'm in CodePen. I'm going to be using CodePen for most of the examples here. The way to get the Google Maps API onto your page is a simple JavaScript include. So here it's just maps. There's the URL you can see with my key at the end of it. And so that's kind of how you use it. We're going to use this basically the same HTML and CSS for the rest of the night. It's just going to be a single div that's going to be where we're targeting the map to be placed into that div. And for these applications, can you all see the CSS in the back, or do I need to make it a little bigger? Okay. Basically, I've got some simple CSS that I'm making that div take up the full screen. But in your mapping applications, obviously, you could have it in a portion of your JavaScript application, or it could be a full screen thing. Now, getting into the good stuff here, Google Maps is pretty simple for creating a basic map. When you include that JavaScript on the page, it puts a global variable called Google into your page, and you create a map using google.maps.map. You've passed it 2 parameters, the first one being a reference to the DOM node of where you want your map to be placed. So I'm just using document.getElementById here, and I'm passing my ID of that div that I had. And the second parameter you're sending is just an object with all the properties or all the options that you want to use when creating this map. So here we've got a center, initial center point, and an initial zoom level, where the lower zoom will be zoomed really far out so you could see the entire globe, and higher levels up to, I think the max is probably like 20 maybe, gets really zoomed in. So you can start to play with this, right? So let's put some different lat longs in here, make it a little more local. Okay, so now we've got St. Louis. Maybe we want to make our initial zoom a little higher, so we're zoomed in. 15. Okay, so we should all recognize this, right? This is where we are at the CIC. Another thing that Google has done recently is that have you all ever been scrolling on a website, and then your mouse goes into a map area and it starts zooming instead of you keep scrolling? So infuriating, right? So they've changed recently the defaults. So if you don't make any changes to this, your scroll zoom actually doesn't do anything anymore to try and combat that. So I think it's a pretty good idea. But if you have a full screen map application, which is stuff that I often build, and depending on the app that you're doing, this might make sense, you can definitely turn that off. So that's called gesture handling, and you call it greedy because you're gonna take the mouse scroll back away from the scrolling page, and when we run this, we should be able to see our scroll wheel working as normal. So that's kind of how that works. Putting a point on the map in the Google API is really simple. They call it markers. The default is that nice red dot or nice red push pin that we all recognize. So let me hit this. Here's the same mapping application that we were just working with. I've created my map, and I've assigned it to the variable map, and now I'm going to put a marker on this page. So I'm going to uncomment this code. Putting a marker, like I said, is super easy. Similar to the map, we're just going to call new google.maps.marker. This time we'll just pass a single object as a parameter with all the options that we want. The position will be where we want to place that marker. In this case, we're passing a variable called home, and that's just an object representing the latitude and longitude. And we pass a reference to our map variable that we just created above, and you can pass it a title, and there are a ton of different options that you could send it. But when I run this, we should get a point right here at the CIC, and there we do. You can also do, yeah, like I said, a lot of different cool things. Animation, I think dropping the point in kind of is an interesting idea. It kind of allows you to focus your user's attention on a particular location. And you can even do, if you want even more, I think this is the scrolling marquee of mapping. You can do bounce and just have it bouncing there for however long you want. So that's just the tip of the iceberg. You can obviously do a lot more as well. Let me grab some code here. Going a little bit more into markers. What would we want to do, or how would we put multiple markers on the page or on the map? Copy in some code. Let me talk through this a little bit. So before, when I was creating this code, I grabbed all the lat long values of the Metrolink stations here around the Central West End. I grabbed 4 of those and just put them into a simple JavaScript array. And then what I'm going to do is, lost my mouse. What I'm going to do is loop through those. So I'm going to loop through what I'm calling stations and call my add marker with timeout on each of those stations, and also pass a second parameter of a millisecond value, which is going to be the milliseconds after the page loads that we're going to drop that point into the map. We'll probably want to zoom out a little bit, so let me do this. And what does our function look like? It's pretty simple. We've just got our create marker code like we did above, with just setting the position to the position of the object that I have in that array, passing a reference to our map object again, and the animation like I showed before. And then we're just adding it to an array. So when I run this, we should see a bunch of markers kind of drop into the map. And that's kind of the basics of how you might add multiple markers to a map if you want to do that. The next thing you might want to do is a very standard mapping thing is, well, I want to be able to click on this marker to see some information about this, right? So in the mapping world, that's typically called a pop-up or info window, which is kind of confusing because pop-up is the same as the browser pop-up, but we deal with it. In the Google Maps world, they do call it an info window. So if I uncomment this code, we'll see new google.maps.info window, and then we're just passing a content property, a string in this case. And in our loop, when we call this on every single point, we're just going to set up a click event listener, and we're going to open up that info window when the point is clicked, and we pass a reference to the map and then to the marker. So when we run this, our points will pop up there, and now when we click that, we can see that pop up. So obviously here we're doing the same message on all of them, but you can kind of intuit pretty easily how you might put a different value in those info windows for each one. And so this is kind of like the basics of putting points on a map. So yeah, so those are the basics of Google Maps. You can certainly do more with that API. That's really just the very bare minimum surface. But I think it does shine when you're trying to do something basic on the map quickly. Leaflet.js supports a few more advanced use cases, and yeah.
What are examples of some things where you'd have to pay to use Google Maps? I'm trying to distinguish what I could do for free.
Yeah, that's a good question. I don't have it all memorized, but I believe it's mostly about, and maybe someone out in the audience knows, but I think it's mostly about the amount of usage.
50,000 page views a month or something like that.
Yep.
And then when you start adding in services like geolocating or something like that, that goes against your, there's 2 or 3, it's very sophisticated, but it's something in that realm. If we do a lot of geolocating, add it really fast.
Cool, thanks for the question.
It's for small business, it'll be fine. If you're doing a major mapping application, you'll run into it.
Yeah, one of the things that we ended up doing on a project a while ago was we had a database of like client locations JavaScript to go out and do a batch geolocation of all the information, all the locations, and then cache that with the client record so that you could just refer to that cache instead of like doing geolocation.
That's exactly the workflow. The opposite workflow where you just geolocate every time is how you overrun your tier.
Yep.
That's very, yeah, super common.
So if you, if you need to do something on the fly or you're not going to do a whole bunch, doing it at runtime is fine. If you have a large cache of geolocations that you can just like get the information ahead of time, it's nice to do it in a batch and just store that information.
Yeah.
It's not like buildings are going to move.
Yeah, I'm going to actually show that later, so thanks for bringing that up. That's good. Cool. Yeah, so Leaflet is super popular. It's a lot of developers like it because it's like super lightweight. The basic include is like very few kilobytes, and you can add things onto it. Obviously, it's open source, and you can easily bring your own base maps. And I think it's very popular in the community. So we'll go into that a little bit here. For all of these APIs, I'm going to basically show the initial example. So let me just do that here. So to get started, let me go into the pen settings again. You have to do one extra thing than Google for Leaflet. You actually have to include the CSS. So here we're including our leaflet.css from our CDN and also including our JavaScript from our CDN as well. We've got a big gray screen, but no, it's not. I don't have an error here. Actually, Leaflet does not show any layers by default, including a base map. And so this is actually properly loaded. Looking at the HTML, same as before, we've just got a single div with our ID map. Basically the same CSS as before, we're just making our map the full screen for demo purposes. And then let's get into the good stuff, the JavaScript here. So the Google Maps API puts that Google variable global out there. Leaflet puts the letter L, capital L, out there on a global, so that's what you'll get used to using for Leaflet. So here we're creating our map with a single line, l.map, and we're passing the div ID of the target div that we want to place our map into. Then we're calling setView on that with two parameters, just the lat long and an array, and then the zoom level. And I think the zoom levels are very similar to Google, if not exactly the same, in terms of the 0 to 20-ish. So we can grab a base map. There are a lot of open source, or I guess open base map services out there. Let me open this up. There's this nice GitHub website, leafletextras.github.io/leaflet providers, that goes through a bunch of base maps that people have out there, and you can kind of click through them and see, which kind of base map you like, and see if it needs an API key or not, and then you can just grab the JavaScript from right here. I guess that's pretty small, but they give you the JavaScript, the Leaflet JavaScript, to just include yourself, which is kind of nice. So that's definitely a very useful website that a lot of people who use Leaflet use a lot. I've got one in here. You can look at the code to create this base map. We're actually creating a tile layer, and you can see that there's some squiggly brackets in here that are kind of almost like a template language, and that is kind of what it is. You're basically telling Leaflet, like, okay, for the X, Y, and Z zoom level, here's how you actually get that image, and that's why the word that X, Y, and Z comes from in that URL. That's the first parameter. Then the second parameter is just a bunch of options. Again, here's like the max zoom level of this base map and some attribution. And then we call .addToMap function. This will be very common in Leaflet. Basically, anything that you want to add to the map, you can call .addTo and then pass your map variable to get that onto the map. So now when we run this, now we've actually got a map, and it's looking pretty good. You can see that the Leaflet controls by default are much simpler than Google's. Literally all it is this plus zoom plus and minus button, and then some attribution at the bottom. So it's really one of those libraries that you can keep simple pretty easily if you want it, like the UI to go away and you want people to focus on your map, which is nice. Let's see what we got next. So jumping into just markers a little bit for Leaflet. Super simple. I think it's even simpler than Google to add a marker onto your map. It's just l.marker, and then you pass the location of where you want that marker to be. For Leaflet, you don't pass an object. You actually pass this. You actually create a new object using l.lat_long, and then you can pass your latitude and longitude as parameters. And so that's what I've done here. I've just put that in a variable called home. And then, like I said before, I'm calling .add_to_map. So when I run that, it's going to assume, because I didn't give it anything, it'll assume to use this blue push pin. That's kind of the default Leaflet. And you can often kind of notice a Leaflet map if you see blue push pins like this, because these are kind of the defaults. GeoJSON is very popular in the Leaflet world. GeoJSON, how many of you have used GeoJSON? Okay, a few. It is exactly what it sounds like. It's basically JSON, but there's a specification where you can add geographical data to it in a specific structure, and it's actually an IETF standard. It came out, it got ratified, I think a while back, so you can kind of read through what it looks like, but it's really pretty simple. So let's take a look here. We can add a GeoJSON layer to our map. I've got I think I found this. Yeah, this is out on the St. Louis County Open Data website. Here are the Metrolink stations, keeping with that theme of the entire St. Louis area. And this is kind of hard to read. Let me open, let me go to JSON Editor Online, pop this in here, format it. So GeoJSON looks kind of like this. You can have a name, you have a type, which is typically feature collection, and then it's just an array of features. So you can see here that's just, it's an array of objects. Each object is in this case, is of type feature, and you've got a geometry, which can be like a point, line, or polygon, like I talked about earlier. In this case, we've got a bunch of points, and it has the coordinates. There's your lat_long. And then it can have a bunch of attributes in this, or they're calling it properties. I don't have any properties in my GeoJSON, but if I did, it would be I think it would be either an object or an array of just attributes for this. So typically, something like the name of the point and all that other information that you want to store on a geographical point or feature. So that's what GeoJSON, some basic GeoJSON looks like. So let me uncomment this. So it's pretty simple to add a GeoJSON layer. I'm just using the JavaScript fetch API to grab that JSON as text. Then I am creating a JSON object out of it, and then I'm loading it into a GeoJSON layer using l.geojson. And I'm passing the JSON object that I have. Then I'm calling, same as the first two times, .add_to_map. And that's just going to add it to my map as a layer. So let me run that. So there we go, and we've got all the Metrolink stations in the St. Louis area, which is cool. Yeah, so there are a ton of different layer types. Really, in all these libraries, there are a bunch of layer types, but certainly in Leaflet, they've got a tile layer, which is kind of what our base map is. There's video overlays. There's lots and lots of different layer types in Leaflet. So definitely, if you have like different types of data, Leaflet can be good. And Leaflet, although the initial JavaScript load is very small, they've got a really good plugin kind of ecosystem of where people can create little Leaflet plugins, and that'll add functionality to your map. So Leaflet plugin, like creating a heat map, right? You can load a plugin that'll do that, or lots of different things. It's a great open source community, and it's a really good tool. So definitely check out Leaflet.
There's
Yeah, yeah, it's completely free. It's an open source project.
You do run into that base layer map.
Base map?
Yeah, the base map, depending on where you get that from, you're either going to have availability issues or you're going to run into request
Yeah.
throttle.
Yeah, that's a good point. I should have brought that up. That, yeah, like on that page, you can see some of those, I think I still have it open here. Some of those, when you're popping through here, you'll see that it requires an API key, like right here, right? So you definitely want to check where you're getting those base map tiles from.
Tiles won't show up sometimes.
Yep, yep. Cool. So getting into the third and last JavaScript library here is the ArcGIS API for JavaScript. I'd say it's the most map geeky of the bunch. There's a whole world of people that you might not know about. They call themselves GIS professionals, and I work with them. They are people who study GIS and work for like cities and counties and companies, and they kind of use Esri and ArcGIS more. It's easy to get going with a basic app in the ArcGIS API for JavaScript, but it's really definitely leans toward people who are doing more enterprisey or big mapping applications. You can do 2D or 3D out of the box, which is kind of cool. They've got a bunch of widgets out of the box built in. ArcGIS is a company. So there's a free tier, but there's definitely a commercial level as well. So if you're a commercial company making money, you probably have to pay them licensing money. So keep that in mind. But it is the API that I work with the most. I work for it on my job, and I really enjoy it. I really think it's a great API. So I wanted to kind of include it tonight and show you guys a little bit about it. So getting that basic map out of the way here. Let me open this up. So I'm initially loading the 3D version of this map. So you can see it's got a lot of controls, a lot more controls than leaflet certainly over here. In addition to the plus and minus button, there's kind of these controls that allow you to kind of control the globe, right? And so you need to do that if you don't have like a mouse. Including the API is similar to Leaflet. You've got your CSS that we're loading from a CDN, and then a JavaScript include that we're loading from a CDN. The HTML and CSS, samesies. We've got a single div where we're going to target where we want to place our map into, and then in our case here, we're going to make that div the full width and height of our window. The JavaScript's going to look a little bit more complicated here, so I'll kind of get into that. So because this is, I think because the API is a little more enterprisey, it uses the require.js AMD style includes so that it doesn't conflict with any globals like the keyword Google or the letter L might. So this was popular a few years ago. I don't think you see AMD as much anymore, but it's definitely a common kind of like spec out there. And so it's a way to kind of include modules that you want to and name them kind of similar to kind of like an object-oriented type include pattern. So in this case, I'm including like the map library, the scene view, and map view. And then I'm giving those variable names, map, scene view, map view right here. And then those are the names that I can refer to them actually in my function. Once I've got that all kind of set, it's kind of similar to the previous APIs, except that it actually separates out these concepts of the map separated from the view. Because you can switch between 2D and 3D, so there's a little more separating out those concepts into different objects. So here I'm creating a single map, and you can see that I'm only sending it one property, base map. And because the base maps, you can use the Esri base maps right out of the box. So you can use base maps using these keywords. So this is the street space map, for example. That's kind of focused on transportation, but you can definitely switch that to, say, run the satellite view, and that would be, you know, seeing the Earth, and then the dark gray or hybrid or stuff like that. And then when I'm actually creating my view, which can again be in 2D or 3D, that's where I get into configuring where I want my initial center to be, my initial zoom level. So similar to before, let's not zoom into Australia, and let's get a little bit more local here and set my zoom level. Similar zoom level concepts, those are common across all three of these APIs, that zoom is generally 1 through like 20-ish. So here we go, here's our CIC area, and I can zoom into that and get pretty good kind of imagery right out of the box. And now down at the bottom, this is really taking that map concept and my view options and putting them into the actual view. So I can either do a 3D view, which is what I'm doing right here, by just creating a new instance of the scene view and passing those options, or I can create a new that was weird. Or I can create a new instance of map view, and that'll create me a 2D map if I run this. So now it's kind of, I guess it's hard to really tell, but the controls aren't, the 3D controls aren't there anymore. And then if I try to do stuff in 3D, it really just rotates the map now. So that's kind of how that works. So that is so that's the basic map. So there's a little more code involved as well, a little more customization you can do, or that you have to do out of the box when you're putting points, basic points on a map. Before, with Leaflet and Google, I just kind of basically gave it a lat long, and it assumed a bunch of stuff about what I wanted in terms of like the push pin look and feel and all that good stuff, where the ArcGIS API doesn't assume that for you, and so you kind of have to define it. So that's where this concept of a graphic comes in. So a graphic is basically the location, the geometry, like the lat and long, plus the kind of look and feel of what I want my symbol to look like, and you join those, and that's what is called a graphic. And so here you can see I've got the location being our CIC, and I'm actually defining out a red circle if I scroll down here. We could define out this point symbol, and we're defining all the different aspects of it. So I want it to be red, I want it to be a certain size, and I want it to be a circle. And so I'm creating that, putting that into this point symbol variable, and I created my geometry up above that I put into this point variable. And then at the very bottom, I'm just creating a new graphic that joins that point and the point symbol into one graphic, and then I'm adding that graphic to the view. And so you've got a lot of different options here. We could change it to square and like blue, all the standard options you would want. Like you can actually tell it a color name, or you can tell it a hex code, all that good stuff. And you can kind of customize how your map looks. Now if we wanted, so that's using kind of this, what's called the simple marker, right? It's just very, very simple. You can give it those attributes. If we wanted to say, put an image there, that's called a picture marker. So I can just paste this code in here. And because we're doing a picture marker, it takes a few different parameters. In this case, a URL to an image that we want to place on the map, and we give it a width and a height, and then it just will use that in the same location that we were before. So if I run that, we've now got a image there, in this case a star, but this is how you would do like a push pin like we were doing before, or something like that.
Would that take SVG as well?
I think so. I'm not totally sure, but I can check into that for sure. Yeah, so that's graphics. Do I have anything else? Okay. So I'm getting to the end here. I did want to get into one kind of slightly more advanced mapping concept that it's called renderers, and the same concept is kind of shows up in basically all the mapping libraries. So I did want to touch on this topic. We've just done basic stuff today, right? We've added points to a map, but the most obvious thing that you want to do next when you're creating maps is, or the next thing that most people want to do is say, okay, I have some points, but now I want to show them different colors or different shapes or different sizes based on what that is, right? Or based on the attributes associated with those points. So you can definitely manually do that using the methods that we've done in any of these libraries, right? We've shown how to put points on the map, and you could loop through it and change the symbol, but that would kind of be a lot of work and a little wasted effort to do that for all of them. So it'd be nice if we could tell the mapping library just like a rule or an algorithm of saying, hey, if you have this certain attribute let's say if it's the city is St. Louis, I want it to be blue. If the city's Clayton, Missouri, I want it to be green, or something like that. And that's where renderers come into play. So in the ArcGIS API, there are a couple renderers. They're named different depending on how they work. This is a simple renderer. The simple renderer is just what it sounds like. It does nothing but shows a single style. So here we've got the U.S. freeway system in lines. That's probably hard to see, but it's just showing a single color, this light blue, no matter what the attributes are. The unique value renderer is a very popular renderer, and it's kind of what I was just explaining, right? So here we've got a map of the U.S. highway system, the same map of the U.S. highway system, and we've got attributes on those for the freeway type. And if the type is of type interstate, then it's going to show in this blue color. If it's of type U.S. highway, it's going to show in this orange color. And if it's of type state highway, it's going to show in this fuchsia color. So that's kind of the unique value renderer, what I was just explaining. And if you take that same concept and say, instead of like operating on strings, I want to operate on like numerical data that I have, then you would use a class breaks renderer. So this is another very common map type that you probably see all the time. In this case, this is in Seattle, and we've got the percentage of adults who have a college degree based on block groups, I think. And the higher the percentage, if it's greater than 75%, it's showing in this dark blue. And if it's low, it gets lighter as it gets lower. And so that's based on similar idea. That's an attribute, but it's a numerical attribute that we have, so we can kind of control it. And that's kind of class breaks render. Okay. So let's get into a demo here of renderers. So I wanted to pull together some local data for this demo, and I thought, we're all developers. Who all drinks coffee from Caldi's? Yeah, any fans? I'm a fan. A nice St. Louis brand here, and so I grabbed all the Caldi's coffee locations in the St. Louis area, and I put them into a CSV. Now I could have taken the easy route and put the lat long into here, like you were talking about earlier, Chris. But I didn't do that because I did want to show how to geocode, which is kind of what we were talking about earlier. Geocoding is the process of converting these addresses into location data, typically lat long, and you can do that either on the fly with any of these APIs, like we were saying, or you can do it kind of in batch, and you can upload it to a service, and a service will geocode those addresses for you. There's free services online. There's pay services online. If you just search geocoding, you'll find a ton of them. I'm just for simplicity today, I'm using my free developers account with the ArcGIS API. So I can just go to the dashboard here, and I'm going to click import data. Oops, and of course I'm going to be logged out. And I will upload that file. And it's going to look at that CSV that I just had up, and it's going to kind of look at the data. And it's going to try and guess out of all those columns kind of what my data looks like. So it's going to ask me a few questions, like if we can assume that all of my addresses are in the United States, then it can probably be more accurate, right? It's going to make certain guesses for those addresses. And then it's going to ask me, well, here's my CSV columns. It's going to say, you know, what is the address column? And it kind of guessed the address. It guessed city, it guessed state, right? But if these weren't right, I could choose the right column in my CSV that contained my zip code. We'll ask a few more questions. What are the types of the columns in your CSV? I'm just going to leave that by default. And this is going to create a map in my account. So it's kind of asking about some security stuff. So I'm going to just leave those as default. But now it's going to actually run the geocode. So what's it doing behind the scenes? It's kind of got all geocoding services. And this is a whole separate world of GIS study as well, how to design a geocoder, but they've got like different levels of data, and they're kind of like figuring out based on this address what's the best guess that we can give for a particular address, and it'll oftentimes your geocoding service will give you a confidence level, right? So I'm either 100% confident that this is here, or I'm only a little bit confident that this address is right here. And yeah, you should be able to find good geocoding services online for pretty cheap. There's free services, but it shouldn't be very expensive even if you are using a pay version. So you can see here I've got it already put my points on the map, so it's kind of ruining the surprise. But I'm gonna hit the REST URL on this data so I can get the data out of it. I'm gonna put in some settings here just to get all my data back. I'm gonna set my output spatial reference to, I want lat long. Does anyone remember what number I need to put in here? WGS84, 4326, yep. And so that's something that a lot of these geospatial platforms will offer you. It will, kind of one of the services that they offer is like translating your geography values into different spatial references. So for this example, like I'm literally putting in that I want it back in lat long, but I could ask that I want my data back in a different spatial reference, and it would do that kind of on the fly for me. I'm going to say I want JSON back here. And I think that's good. So now I'm going to get all those points back in a JSON format. And so this is getting into a little bit more deep into the ArcGIS JavaScript API, but we'll just plunge ahead here. We're going to create what's called a feature layer, which is a little bit different than what we've been doing earlier. Before, in the other APIs, we've kind of been doing what we would typically call a graphics layer, which means we can just put kind of anything on the map. We can put a point, we can put a polygon, we can do really whatever we want, and it'll show up. The concept of a feature layer, at least in the ArcGIS JavaScript API, is saying, okay, well, I want all of that, but I want to be able to make certain assumptions on my layer, so we're going to enforce some rules. And so in a feature layer, we're going to say all of the geometry types of all the items in this layer are the same, right? So I have either all points or all polygons or all lines. And it all has the same schema as well, right? So every single one of my points has the exact same data attributes on them. And so when you make those assumptions, you can start to do things like do renderers because you can make assumptions on the schema and the type of the geometry in that layer. So that's what we're doing here. I've included the feature layer at the top. And I'm going to this layer variable, I'm going to create a new feature layer. And I'm going to put all that JSON data that I just got into here. I do have to make a few small changes, which would be easier if I had my mouse. But we'll power through. So in these features, I'm going to change this to source. You probably don't have to worry too much about this. And then in each of these features that I'm getting back, I'm going to set a type just so it knows the type on all these is of type point. Do that, and do that. So now our data should be in a good spot to, oh, I have one more, to show. Now I run this, but you'll notice that I haven't actually created the renderer yet. I haven't actually put the renderer in there, so it's not actually showing anything. So let me grab the renderer code. This is going to be some JSON as well that we're going to define out the rules or algorithm for our renderer. I'm just going to put it at the top of this, this JSON object where we're defining the feature layer. And let me make it a little bit bigger. Let me format this. Oh, there we go. Okay. So, like I mentioned, this is kind of the renderer code. This is for a unique value renderer. And like I mentioned before, we're going to choose a single attribute column that we want to base our renderer on. So in this case, we're going to look at the city field. So we're going to say, for all these points, I want to change the look and feel of the point depending on what city that Caldi's coffee location is in. We define a default to say, if it doesn't match any of my rules, it's going to be a simple marker symbol that's red. And then I'm going to be able to define a bunch of other rules in this unique value infos to say if the value is St. Louis, I'm going to make it blue. And if it's Clayton, I'm going to make it green. So now if we look at the map, there we've got our map. And looks pretty good to me, right? Yeah? Okay. So there we've got St. Louis, Clayton, and all the others is our red. And I've also included this legend. I didn't talk too much about that, but that's kind of one of the out-of-the-box widgets. I'll bring that up in a second here. So that's how to do the unique value renderer. Just switching this over to be a...
Hey, just real quick, why did you have to change features to source?
yeah, that's a good question. It has to do with that geocoder that I used and the JSON format that it used. That wasn't using GeoJSON. It was just using kind of a specific to Esri JSON format. So that's why I had to kind of change it when I put it into the API. But if I was using GeoJSON, it would have probably been easier, and because that's kind of a more consistent, that everybody knows that format. So now I'm going to create a class breaks renderer. So if you remember back to our CSV, I have the open and close times for each of these locations. And I thought maybe, it might be interesting, like if you were creating a mapping application that you wanted to give to like college students or anybody really, that you want to show the Caldi's locations that are open the latest on Sunday night, trying to get your homework done before Monday, right? So that's kind of what we'll try to build here. So I'm just going to change my render. Instead of being a unique value, I'm going to change it to class breaks. And the field that I'm going to look at is the Sunday close time. That was the column name of the CSV that I had. We don't need default symbol anymore. And instead of unique value infos, it's going to be class break infos. Class break infos. And luckily you don't have to watch me type all that because I've got the class break infos over here. So I'll copy this in. Now what did I just copy in? Well, it's kind of a similar concept, right? So for class break infos, I'm basically giving it a minimum value and a maximum value this time because I've actually got integers that I'm comparing. And if a particular point or Caldi's location, if the Sunday close value is between 1500 and 1799, like 3 and 5 p.m., in other words, it's going to use this symbol. In other words, I'm going to make it a circle, and I'm going to use this color code in this size. And so, and I forget what color code that is, but it's basically saying the earlier it's going to be a lighter tan, and the darker, or the later it goes. So for example, 6 to 9 p.m., it's going to be a little bit darker color I'm defining, and then 10 p.m. to midnight, it's going to be a still darker color. Obviously, I could change these other values in here as well, like we could mess with the style or the size depending on attributes, but we're just keeping it simple for now. So I think that's all I got. Let me run it. And so there's our legend, and there's our points. And I think this, this example really shows how you want to choose your base map, right? Because those in the back, you probably can't even see those tan point or the orangish tan points on this the base map here. So this really shows how you want to choose your base map wisely. If I scroll up here, I might want to change my base map to say dark gray. When I rerun it, see how the points really pop a lot better if you're on a dark gray base map. So there you have it, right? I guess this location, I think this is the location in, right in U City. Is the place you can drink your coffee latest on a Sunday night. So there we have the answer right there. So just a few more quick things here. The widgets I did want to show. The widgets are really cool in this in the ArcGIS API. You can include them just with that single AMD include, and then it's really kind of a one-line thing to add a widget. So here I'm adding a search widget. So when you're creating a mapping application, it's very, very common to want someone to be able to start typing an address, have it autocomplete right as you're typing an address, and also do that geocode, right? You're putting in, and so you have to do kind of those 3 operations at once. It's a very common thing, and so that widget comes out of the box. I'm just literally creating this search widget. I'm passing it the view, and there's this kind of widget framework where you can just place a widget into the map, and you tell it like a top right, bottom left, that kind of thing, and that widget kind of comes with it. So I can start searching for like Clayton, Missouri, right, and it auto completes, and then when I click on it, it zooms there. So that was all, I didn't have to write all that logic. It was just basically like a one-line include for that widget. And there's a bunch of them. There's like this home widget as well. So as soon as you're allowing someone to search for somewhere and go somewhere else, you might want to allow them to come back home. So I've put this home icon there. So now when I search for Clayton, I can click home to go back home. So just things like that. It's kind of nice to have those widgets out of the box. I think that concept is kind of across the board in all the libraries, but definitely something to be aware of, that like, hey, if you're thinking of, hey, I want to have a search widget, something probably exists out there already in whatever mapping library you're using. Cool. And then the last thing I wanted to show, just because this is fun, 3D is kind of I think it's still a little bit novel in the world. Like a lot of mapping applications that I see aren't necessarily using 3D yet, but it is on the upswing. People who have 3D data really like to use it, and it really creates compelling maps. And I just kind of wanted to show that here. So I've got a map that's, does anyone know where this is by chance, what this is? It's Mount Everest. But you wouldn't know that, right? Because it just looks flat. So I can actually create I can actually include the ground elevation here with just one level. So when I'm actually creating my map object, I'm going to say the ground is world elevation. And when I do that, it's automatically going to, when it grabs the base map, it's also going to grab the elevation data from a service on ArcGIS.com, and it creates a pretty compelling view here. So now you're going to see that just pop up, right? And so now you can really get a sense of what's going on here in terms of 3D. And so this is why I think 3D is really going to get more and more popular, because just like, especially when you have a compelling use case for 3D and you can do stuff like this, it really makes a really great immersive interactive application. And then when you actually start having widgets that go along with that 3D data, so for example, the ArcGIS API has a 3D measurement widget, which is pretty cool. Let me run this. So I'm just going to click a new measurement, and you can see I'm going to click on the map here. It's kind of hard to do on such a tiny screen, but I'm going to click the top of the mountain, and you can kind of see here it's putting those measurements in 3D space, right? So it's really kind of cool thing, and you can even like drag things. So there are a lot of mapping libraries that are kind of doing this along with the ArcGIS API, doing some cool stuff with 3D. But this kind of just shows you how interesting and compelling the application can be if you really have that data and you want to do something like that. I've seen a similar demo with like actually measuring like a building or measuring the Eiffel Tower or something, right? That gets you into like the real world applications of some of this kind of stuff. So it's you can really do a lot with it depending on what you need it to do. Cool. So yeah, those are 3 APIs that I kind of wanted to go through. Again, there's a lot out there, so don't limit yourself to these 3. Do your research. Which one should you use? In my opinion, if you have allegiance to any library, just like JavaScript, frameworks, go with that, right? You can probably do what you want to do in any of these libraries. To be completely honest, they're really good. I think Google Maps, really good for consumer-facing things, really great if you want to have business data or if you want to use those street view aspects. Leaflet is really great because it's small and open source. It has a really active community. And then the ArcGIS API is a little more enterprisey. You can do a lot with it. You can do 3D, but if you're doing commercial stuff, you might have to pay for it. And but that might also be a good thing if you want support and an enterprise level thing. So pros and cons of all of them. Bottom line, I think it probably depends on your situation and your project. But hopefully you've learned a little bit more about maps tonight. I really enjoy them. I think adding a map, if you have the correct data, can really add to your application and can help your users understand your application or understand their world just a little bit better. Yeah, go out there and map. So thank you very much. So I guess a few minutes for questions here, if anybody has any. I don't know. I mean, does anybody know? I mean, I don't know if Leaflet can do 3D out of the box. There might be a plugin that you can do. Google, I'm not sure how you do 3D.
Google has, their Google Maps is 3D, but I don't know if it's exposed to
Yeah, I'm not totally sure. But
the same guess for Leaflet.
yeah.
The plugins are very.
And I think there are other libraries. Let me go back home. I think there are other libraries that are really focused on. Yeah. Yeah. Yeah.
What was the other one? The first screen you had like a bunch of logos. There was one of them. The ones that don't have a name in them.
Oh, yeah. So yeah, Cesium, ArcGIS, Leaflet, here, Mapbox. That one down there is Open Layers. That's kind of the one that like, it's in the GIS world. There's like 2 desktop softwares, or there's a few desktop softwares, but there's one called QGIS and open layers is kind of typically used with that, and then Google. Yep.
If you're, whenever you're drawing the polygon onto a map of like a specific boundary area, are you, with each of these, are you just defining like each of the, like are you drawing it like vector where you're using geolocations to define the points and then saying draw lines in between, fill in the center?
Yeah, absolutely. Yeah, so you're saying when we're putting a polygon on the screen, like how's it kind of stored in the background? Yeah. That's in like in GeoJSON and really in all these libraries, it's basically storing your points, and it's just connecting those. Yeah.
Gotcha. Do you usually have to like figure out each of those points by hand, or do you like or do some of the tools allow you to say like if you're drawing like the St. Louis boundaries,
Mhm.
I'm assuming that you're not having to figure out the actual.
Oh yeah. You mean like so if you want your user to be able to literally click and drag on the map to draw?
No, or well, if you had a map where you were trying to highlight like the Tower Grove area, like and like just put an orange box over it or
Mhm.
something like that, would you have to figure out each of the points that make up the boundaries of the Tower Grove area yourself, or do some of these services will they like if you
Oh, like have the data for you. Oh, yeah, that's a good question. Typically you'll find the data. Yeah, so you'll either go to like an open data website, or yeah, you might create it yourself. Yeah, so like ArcGIS and Esri, they do offer some data for you. So depending on how deep the library's company is into like providing data, they might provide it. But like Leaflet doesn't really like deal with data, right? They're like Leaflet is very much just a library, and you bring your own. Yeah.
So this was a couple of years ago, and I don't remember why I was wanting to do this, but I know I did something with Google Maps where I was wanting to outline certain areas, and I was able to make it so that I could zoom in on the map and click, and I just had it writing into the DevTools console what the lat long was where I clicked, and then I gathered up all of those, and then I could draw the outline. Maybe there's a better way, but that's a very
Yeah.
brute force way that you could do it.
Yep. Yeah, for sure. All the libraries we had today have what are typically called drawing tools that you can enable that are pretty easy to do what you just said, right? Allow the user to click on the map and maybe it gives you back the point, or you can enable the draw tools and say, I want the user to be able to draw a polygon, right? And then they can literally just draw a polygon and you can get the geometry back there. So yeah, they all have higher level helpers for drawing.
When I was doing agricultural crop data, we literally got points off the tractor.
Yeah.
Because all modern tractors now have GPS on them. So we would just find extreme points of the route that the tractor made.
Yeah, for sure.
Field done.
Yeah, and I love I've dealt with a little bit of agriculture data too at my job, and I love the agriculture story because it just really shows you how like in weird industries or in industries that you wouldn't expect there to be mapping and geo data to be, there often is, and it really kind of made me start thinking more and more about like, oh, I'm doing this, but is there a location aspect to this data?
It's rather extreme in farming.
Yeah.
Nowadays.
Yeah.
It's surprising.
Yeah, and it's great for all of us, right? Because if they can do smarter things with location and where they're planting the crops and planting the proper crop in the proper area, then they can use less fertilizer and it's better for us all. So I love that technology for sure. Any other questions? Well, I'll hang out around here. So thanks everybody for listening, and my slides are out there. So hit up that link if you want. So thanks.